Hello students, today we'll see a new topic, simultaneous equation, and we will solve by the coefficient of variable methods. Uh, this topic is common in 9th standard as well as 10th standard. So we'll see various levels of sums. I will try to tell you some easy tricks, easy way, systematic way by which you can do it. So let's start. Before that, my name is Santanu Das and I have been teaching from the last 27 years. And here I will try to explain you the various topics in maths in an easy language so that you can solve them without any fear. Today we'll see one of the most common method of solving simultaneous equation, that is coefficient of variable method. Simultaneous equation by the coefficient of solving coefficient of variable method. This is the most common method by which you will do simultaneous equations, solve simultaneous equations. So first, like always, we will first see the steps that you will follow while doing the sums. First of all, write variables on one side and number on the other. Step 2, make x or y same. Step 3, once you have made x or y same, whatever you have made same, either it will be x or y, both will have same sign or opposite sign. Same sign or opposite sign. If same sign, then subtract, and if opposite sign, then add to get the answer of first variable. Step 4, put the value of that variable in any of the equations to get the value of second variable. So what I'm speaking, you will understand it when I solve a sum. So first, let's take a very simple example. Suppose I give you x minus 2y plus 10 is equal to 0 and 3x minus 5y is equal to minus 12. Now as you can see in the sum, in the first equation, all the terms are given on one side, but as we know from our first step, what we need to do is write variables, that is the alphabets on one side and number on the other side. So we need to write it in this form: x minus 2y is equal to minus 10. The second equation, it's already given in the form what we need, so we will not do anything. We will just write it as it is, 3x minus 5 or minus 12. I have specifically chosen negative sums because students make mistakes in negative. Okay, so that's the step 1 that we have done. Now what we need to do is we want to make x or y equal. Make x or y equal means the coefficient of x should be equal or coefficient of y should be equal. Now look into these two equations. As you can see here, nothing is written. That means there is a 1 and here it is a 3. So if you just multiply this equation by 3, our work will be done, because then this will become 3x and we can solve it. It is very easy to solve that way. But what I'm going to do is I'll make it a little complex again. What I'll do is I will take this part, y, I'll make the y same. Let me tell you, you do it by any way, you are going to get the same answer. So let's give it a name 1, 2. Now, whatever number you see over here, you multiply over here, and whatever number you see over here, multiply here. In case it's a multiple, like for example, here it is given 2 and it was a 6, then it is, as it is coming in 2's table, so you can just directly multiply by 3 to get this 6 and then solve it. In case you get confused, you find it difficult, whatever it is, just exchange. Whatever number is here, you multiply here, and whatever number is here, you multiply here. When you are multiplying that, you have to remember, again, a mistake which students do is they just multiply this number, or just the left hand side. They forget to multiply the right hand side. So you have to be very careful. Whatever you are going to do to both the sides. So in case right now I'm going to make the y equal, so here it is a 5, so I'll multiply this by 5, as it is not coming in 2's table, and here it is a 2, so I'll multiply it by 2. What we'll get is 5x minus 10y is equal to minus 50, and 6x minus 10y is equal to minus 24. So the second step is done. The variable y has become equal. Now we need to, step 3 is both will have same sign or opposite sign. The one which has become equal, that is the y variable, both have same sign. So in case of same sign, we need to subtract. If it had opposite sign, we would have added it. Now we need to subtract this. Subtract, you keep a little bit of gap, and whenever there is a minus sign, all the signs will change of the lower equation. This is minus, so this will become plus. This is also minus, so this will become plus. In case any one of them, this was a plus, it will have become minus. You have to change the sign. In case there was a plus, there was opposite sign and you were adding the equations, in that case, there was no need to change the sign. Whatever, you just have to solve it directly. Okay, so now solve it. 5 minus 6 is minus 1x. This minus plus is going to get cancelled. Minus plus is minus, so that's going to be equal to 50 minus 24 is 26. Bigger number sign, x minus 26, so minus 26 upon minus 1, that's going to be equal to 26. Now what we'll do is, step 3 is done. We got the answer of one of the variable, that is x. Now we want to find out the other variable. So put this value in any of the equation. Put x is equal to 26 and put the value in 1. You can put in any equation, still you'll get the same answer. X minus 2y is equal to minus 10. So 26 minus 2y is equal to minus 10. Which number do we take first? Always the number which is away from the variable. Whatever is with the variable coefficient, that we have to take it last. So minus 2y, minus 10, minus 26. So minus 2y is minus 36. So y would be minus 36 upon minus 2. So first divide, solve 18. And according to the rule, put the sign. Both have same sign, so it will be plus. This we have covered in another video about plus, minus, how to add or subtract or multiply or divide. So the solution, x would be equal to 26 and y would be equal to 18. Y would be equal to 18. Now the good part about this sums are, you can yourself check what you have done is correct or not by just substituting in any of the equation. So if I put it in this equation, second equation, 3x plus minus 5y is equal to minus 12, and if LHS becomes equal to RHS, means what I have done is correct. So you can just do the checking whether what you have done is correct or not. 18 minus 5 into y is, x is 26 and y's value is 18. So you just substitute. This is going to be 6 3s are 18, 1, 78 and 90. 78 minus 90 is minus 12. You can see RHS is minus 12. So bingo, whatever I have done is absolutely correct. So this is how you have to solve the simultaneous equation sum. Now this was a very simple example. Let's increase the level. I give you something like this: x upon 3 plus y upon 4 is equal to 4, and the second equation is x upon 2 minus y upon 4 is equal to 1. In this case, what you see is they are in the form of fractions. Now, whenever you see a fraction, many students get confused how to solve it. So the easiest way to solve whenever you see fraction is take the LCM of the numbers. Like here you have 3 and 4. The LCM of 3 and 4 will be 3 ones are 3. 4 is not divisible, so keep it as it is. And as there are no other numbers, so you can directly take 4. If there was some other number, you should always take only prime numbers when you are dividing. So 3 into 4, so LCM is equal to 12. So whatever LCM you have got, multiply all the terms by that number. So in this case, I'm going to multiply by 12 on both sides. So when I multiply by 12, I'll write it in the second step so that this doesn't mess up. Y upon 4 is equal to 4 into 12 into 12 into 12. So it's going to be 3 4s are 4 3s are. So the sum becomes 4x plus 3y is equal to 48. Okay, now some of the students, they prefer cross multiplying this. That is also correct. You can cross multiply, but the problem is whenever you cross multiply, many times what happens is you cross multiply 4 into x, 4x, 3 into y, 3y. You forget to multiply this, or even if you multiply, you forget to take it there. So the best way, whenever you see fraction, one number having a fraction, two numbers, or all the three numbers having fraction, the best way is take the LCM and just multiply everything by the same number. In this case, just imagine if there was only a 3 over here. Then what we would have done is we needn't take the LCM because there was only one number. Then we would have multiplied all the terms by 3. And then 3 into 3 into 3. This 3 would get cancelled and you would get a normal equation. Okay. Same thing over here. There's a 2 and a 4. So again, we need to take the LCM of that. 2 ones are 2 twos are. 2 ones are 2 ones are. So LCM is 2 into 2, that is 4. So this equation x upon 2 minus y upon 4 is equal to 1. We'll multiply this by 4. Again, a small thing that has to be needed. Students, they multiply here, but they forget to multiply on the right hand side. So whatever you are multiplying, you should multiply to both the sides. 2s are 4s are. So answer is 2x minus y is equal to 4. So this is the first equation and this is the second equation. So once we have got the equation, now again the same thing as I told you, you need to make the second step x same or y same. Now how can we make, if I want to make the x same, as you can see 4 and 2 come in table. So you just, to make this 4, you just multiply this equation by 2 and your work will be done. Okay. But right now again what I'll do is I want to show when there's a term 1 with there's a coefficient 1 with any variable, how you solve, because that is the easiest way to do. So 3y and there's a 1 over here, 1y. So we just need to multiply this equation by 3 and our work will be done. So when I multiply this equation by 3, so what I get is 6x minus 3y is equal to 12. And my other equation is 4x plus 3y is equal to 48. Now we have made the y same in this example. So once we have made one of the variables same, we have to see their sign. You see 3y, 3y, they have got opposite sign. And when they have opposite sign, then we add. So I have purposely taken addition sum, that you know that while adding, as I told you, you don't have to change the sign. You will directly solve. 6 plus 4 is 10x, minus plus means it's gone, 3 minus 3 is 0, 48 plus 2 is 60. Therefore, x would be equal to 60 upon 10, 10 6 6. So x value will be 6. Now again put x is equal to 6 in any of the equations. Let me put that in equation number 2. So the equation is 2x minus y is equal to 4. So 2 into x value is 6 minus y is equal to 4. 12 minus y is equal to 4. Again a mistake. When students, now when they take it there, they forget that there's a minus sign over here and they just write like this. Now things don't vanish magically. When there's a minus sign, don't forget that you have to put that sign. Your number 12 has gone. Why? As it is. It's on the LHS, so you'll keep it on the LHS, right? Left hand side. So 4 minus 12 plus minus minus 12 minus 4 is 8. Put sign of the bigger number. So minus sign from both sides will be gone. So y will be equal to 8. So solution, what you can say is x will be 6 and y will be equal to 8. You can check for yourself what you have done is right or wrong. How can we check? As I told you, you substitute in any of the equations. Suppose I substitute in this equation. I will do in one step. 4x plus 3y is equal to 48. So 4 into 6 plus 3 into 8. 4 6 is 24 and 24. 24 plus 24 is 48. The right hand side is 48. So that means whatever we have done is absolutely correct. So that is another type of sum. The third type of sum that we'll see is when the variable is in the denominator. Now they are quite challenging for many students. So let's see, when the variable is given in the denominator, plus 1 upon 3x minus y is equal to 3 upon 4. And the second one is 1 to 3x plus y minus 1 upon 2. It's a good sum. 2 3x minus y is equal to minus 1 upon 8. So how will we do this? So whenever you see a variable in the denominator, it's 3x plus y or just 1 upon x or just 1 upon x plus y. Whenever there is variable is in the denominator, you can't solve it like this. First step, what you are going to do is we have to substitute for that 1 upon 3x plus y, say a. And for 1 upon 3x minus y, say b. Now you remember all the time, whatever is over here, the other side also, they will give you the same thing. So in that case, what we need to do is, in the first step, we need to substitute the variable with some other alphabets. So in this case, it's 1 upon 3x plus y. For that, we'll put a, and 1 upon 3x minus y, we'll put b. So the first equation becomes this whole thing is a plus this whole thing is b. A plus b is 3 upon 4. Now the thing that I wanted to explain long back, I got it over here. There's only one term which is in the fraction form, and that's in the right hand side. So wherever it is, I don't want a denominator. I don't want a fraction. So I'll multiply. In this case, there's only one number with a fraction. Like in the first example, we saw there were two numbers. Here only one number has a fraction. So I'll just multiply everything by 4. We don't need to take the LCM, just multiply by 4. So this 4 gets cancelled, and what we get is 4a plus 4b is equal to 3. So my job is done. It has become an easy thing. Next one, take it. So you see 1 upon 2 and 3x plus y. For that, there is a a. Don't get confused. Don't write it down. It is 1 upon 3x plus y is a. And the next one is minus. There's a 2 over there, minus 1 upon 2. And b is equal to minus 1 upon 8. Now, in this example, all the three terms have fraction, has denominator in it. So, in that case, we need to take the LCM. We can't directly multiply by the term. So, what we get is 2 1s are 1s are 2 4s are, and just one term remaining. So, you can directly divide 4 4s are. So, 2 4s are, that is LCM is going to be 8. So whenever there are two terms with fraction or three terms with a fraction, then we need to find out the LCM, and whatever the LCM comes, multiply by 8 to all the terms. 8, 8, 8. So what will you get is 8 cancelled, 2 4s are, 2 4s are. So this becomes 4a minus 4b is equal to minus 1. Now if you check the equations, you can see that already a as well as b are same. But whenever both the equations are same, you can see a variable also have the same coefficients and b variable also have the same coefficient. Then don't get confused. Whenever it's that the case, then you add it. Don't try to subtract. As far as possible, avoid subtracting, because then you have to change the sign and there is a chance of making mistakes. So what I'm going to do is 4a, let me write it this side, 4a plus 4b is equal to 3, and 4a minus 4b is equal to minus 1. So let me add it, because the sign I'm considering this and they have got opposite sign. So it's 8a, and this is going to be equal to 3 minus 1 is going to 2. Again, see, whenever there's a plus sign, I have not changed any signs. Only when there was a minus sign, I would have changed the signs of the terms below. So a is going to be equal to 2 upon 8, that is 1 upon 4. Once you get this, don't write 1 upon 4 as 4. 1 upon 4 and 4 are not the same thing. So keep it as it is. Put a is equal to 1 upon 4 in any of the equations. I'm going to prefer the plus term, but I want to explain you the minus thing, so I'll put it in the minus. So 4a minus 4b is equal to minus 1. So 4 into 1 upon 4 minus 4b is minus 1. So 4 gets cancelled. So 1 minus 4b is minus 1. So minus 4b is minus 1, and that the 1 goes there and it becomes minus 1. So minus 4b is minus 2. Therefore b would be equal to minus 2 upon minus 4. 2 1s are 2s. So the answer is, and minus minus is plus. So what we have got is a as 1 upon 4 and b as 1 upon 2. Students, what they do is they are in a hurry. They think that they have got the answer. As you can see, a, b, we have got the values of a and b. But the original sum, check out the original sum. In that, it was in x and y, not a and b. So that means the sum is not complete. I need to resubstitute these values. So how will I resubstitute? 1 upon 3x plus y is value is a, that is 1 upon 4, and 1 upon 3x minus y is equal to b, that is 1 upon 2. So just take the invertendo of this. So it's going to be 3x plus y would be equal to 4, and 3x minus y is equal to 2. Some people prefer to just cross multiply, means you write it this here, write this here, so you'll get the same way. Any way you solve, whatever you find easy, whatever suits for you, you do it that way. So I have written it, and again I find that I've got simultaneous equations. I've got a pair of simultaneous equation. So again the same procedure, whatever we have learned from the beginning, that we need to solve this. Again in this example, what I see is coefficient of x has also become same, y also have become same. So I would prefer plus minus, so I need to add, so I prefer doing this addition. So what would happen is then 3x plus 3x would be 6x. This would get cancelled, and 4 plus 2 would be 6. The value of x would be 6 upon 6, that is going to be equal to 1. And y, put x is equal to 1 in, say, 3x minus y is equal to 2. So that is going to put x value 1. So 3 into 1 minus y is equal to 2. That is 3 minus y is equal to 2. 3 goes that side. Don't forget the sign. Minus 2 plus, it's plus 3. So when it goes that side, minus 3. Again, students think this number's sign is this one. Always remember, a number has its sign in front of it, not behind it. So what is the sign? There is no sign given here, means it's minus. Sorry, plus. So when it goes to the other side, it becomes minus. So it's minus y is equal to minus 1. Therefore, both sides minus cancelled 1. So solution is going to be, the final solution of this sum is x would be equal to, x would be equal to 1 and y will be equal to 1. So that's the answer. So this is how you have to solve the simultaneous equation sums. We have understood how to do these sums, and just for how much you have understood these sums, I'm giving you a challenging sum, a challenge for you. That is, I will give you a sum and you can write the answer in the comment section, calculate it and write the answer in the comment section. And if you can't do it, I will solve for you in the next video. 1 upon 15 and the other is 1 upon 2x plus 1 upon 3y is equal to 1 upon 12. Try to solve this sum and thank you for watching the video.